A and B switched, and it was then B and A in any one of those possible spots. There's actually an extra 2 factorial ways, or 2 factorial ways to rearrange these two people, which gives us 24 times 2 times 1, or 48 possible seating arrangements. It gets even a little bit more complex when we've got person A and person B maybe had a fight, and they cannot be together. So for this one, we've got maybe a bit of a formula which says how many ways can person A and B be together, adding with the ways that person A and B are not together, should represent all possible ways that 5 friends could sit in a row. So the question we're asking is, how many ways can A and B not be together? That's this part right here. How many ways can A and B not be together? How many ways can A and B sit together? Well, we just calculated that as 48. And how many ways can 5 friends sit together with no restrictions? 5, 4, 3, 2, 1, or 5 factorial. And by simply subtracting the 48 over to the right side, we have 5 factorial minus 48, which is a 120, minus the 48, gives us 72 ways for 5 friends to sit where person A and B must not be next to each other. A very powerful tool with a simple bit of logic. To finish this off, we're going to talk about one last thing, and that's solving permutations with repeating objects. So imagine you're playing Scrabble and you're looking down at your Scrabble tiles, and you've got 1, 2, 3, 4, 5 letters left. An A, C, O, R, N. And with these 5 letters, we're asking how many ways can you rearrange these to make new, and I'll quote unquote, words. Now, corna might not be a word, but we're assuming that it's a different arrangement. So just like 5 friends in gym class, 5 people being arranged in 5 desks, 5 positions on a team, we're simply saying there are 1, 2, 3, 4, 5 positions and 5 options. So this is a 5, 4, 3, 2, 1, 5 factorial ways to rearrange these letters, or 120. I won't write the 120, but as we move on to a word boom, we would say there are 4 letters. So 4, 3, 2, 1, 4 factorial. But the one thing that you might be noticing is that those 2 O's match. So instead of saying those 2 O's rearranging make something new, like we needed to do in this example where the A and the B switching make something new, we've actually already considered rearranging those 2 O's. We've said that if this O and this O were to switch, it's something new, and it isn't. So we're going to need to take away by dividing all those rearrangements by the number of ways that those O's could be switched, which is 2 factorial. This gives us 24 divided by 2, or 12. So when repeating objects occur, that in their rearrangement doesn't matter, we must divide out those options. Cheeses was carefully selected because the E's match, and there's 3 of them, and the S's match, and there's 2 of them. There is 1, 2, 3, 4, 5, 6, 7 factorial ways to rearrange these 7 tiles, 7 letters, but there is 2 factorial ways to rearrange those S's that don't matter. There is 3 factorial ways to rearrange 3 E's that don't matter, right? E, 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 3, 2, 1, 3 factorial. And this is a number crunch that we could do in our calculator, but be careful that you've got a 7 factorial on the top and a 2 by 1 by 3 by 2 by 1 on the bottom, not a 5 factorial or a 6 factorial. Those are separate calculations. And for the very last question, we've got a pathways question, which asks how many ways are there from A to B if you're not allowed to backtrack and you can only travel down and to the right. So maybe you travel right, down, or maybe it's down, right, or down, right, down. Lots of options. So you might try these all out and figure out that there's a bit of complexity and maybe you miss one or two, but ultimately this question requires us to at some point travel down twice and right 3 times. So maybe you travel down, down, right, 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 or maybe it's down, right, right, down, right. It doesn't really matter what order you do them at the moment, but it does matter in terms of how many arrangements are possible. So if I pretend that this is a word and these are the Scrabble tiles you have, I'm simply saying you've got 1, 2, 3, 4, 5 factorial letters, the 2 D's repeat, and the 3 R's repeat, and this should give us the total number of ways to get from A to B without backtracking. So we could say down, right, right, or if we map these all out, right, 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 down, down, right, right, down, right, down, right, right, down, down, right, and you keep mapping these all out, you would find out that there is in fact 10 ways to get there. So this really is just rearranging letters in a word, DDRRR. Most people will eventually say, if they get a question, they will take the 2 sort of rows and the 3 columns and say 2 plus 3 is your 5 factorial on the top, the number of rows times the number of columns. So some people, again, will make a formula. They've got rows plus columns on the top, and a rows and a columns individually created. Otherwise, your practice from today is from page 524, 2 to 20, 25, and you can omit number 9. Ultimately, practice is very important for this unit, and you'll find things start to feel more and more comfortable the more you do. Good luck.